perform basic matrix operations. First, let's start with what a matrix actually means. A matrix is an rectangular arrangement of numbers in rows and columns, like shown in this example. The rows would be the horizontal lines and the columns would be the vertical lines. Therefore, the 4, the 1, -1, and the 5 would be a row, and the 4, the 0, the -1, the 6, the 5, the 3 would be your columns. So, in matrices and operations of matrices, it is important to have an equal matrix of the same dimension. A dimension would be, for example, your ratio from rows to columns. In this matrix, you can see that you have two columns, the 4, the -1, the 5, the 0, 6, and 3. That makes row 1 and row 2. And here you would have column 1, column 2, and column 3. You don't always have to graph that, but then if you need that, of course you can. So therefore, the dimension of this matrix would be 2 by 3. That would be the dimension of this matrix. Therefore, if I wanted to find its equal, then I would have to find another matrix with a 2 by 3 dimension. In this, for example, that could be, which is exactly 2 rows and 3 columns. It is always going to be row per column. 2 by 3. Therefore, this matrix and this matrix are dimensionally equal. Alright. The first basic matrix operation there is addition. In addition, any example. So addition in this case would be all about order, placement. They are the same dimension. This is a 2 by 2 equally to 2 by 2. Therefore, these are actually very possible to be added. Any dimensions that are not equal, since everything depends on placement, then it cannot be added or subtracted. Therefore, we do 3 plus -1, since they are both in the same place. We do 0 plus 4 in the same place. We do -5 plus 2 given their placement. And we do -1 plus 0. Each of these answers equal your new matrix in exactly the order that you wrote them. Therefore, your new matrix should equal 2, -3, 4, and -1. It is all about placement. Place number 1 on the first matrix added to place number 1 on the second matrix added equals your new matrix. Subtraction. Subtraction also depends heavily on placement. So you understand with an example with a matrix which is 7, 0, -1, 4, -2, and 6 minus -2, 5, 3, oopsies, -3, -10, and 1. The same as with our addition problem, it is all dealing with placement. Our first place in our first matrix will be subtracted by the -2 on the first place of the second matrix. Therefore, we can write this out as 7 minus -2, 0 minus 3, -1 minus -3, 4 minus 5, -2 and 6, 6 minus 1. Our answer matrix should equal all of these in the same place they were written on. Therefore, your ending matrix would be 7 minus -2, 9, 0 minus 3, -3, -1 minus -3, which is 2, 4 minus 5, which is 1, -2 minus -10, which is 8, and 6 minus 1, which is 5. And that would be your correct ending matrix. It is all about placement. First place with first place, second place with second place, third place with third place, fourth place with fourth place, or however you want to call them. You can obviously do this as repeatedly as you would like if you cannot see mentally, but it should turn out in the same dimension matrix. We move on to the next basic property of matrices, which is the distributive. Distributive property is something that you learn in the basics of algebra. If I have this matrix for -1, 1, 0, 2, and 7, which is a 3 by 3 matrix, and in the problem a -2 is asked to be distributed into the matrix. Therefore, the -2 goes to each of the numbers inside the matrix. So you could say that this was 4 times -2, -1 times -2, 1 times -2, 0 times -2, 2 times negative 2, and 7 times negative 2. Your matrix would obviously be the result of that, which then would equal to 4 times negative 2, negative 8, negative 1 times negative 2, positive answer, so 2, 1 times negative 2, which would be negative 2, 0 times negative 2, which would obviously be 0, 2 times negative 2, which would equal to a negative 4, and 7 times negative 2, which would be a negative 14. This would be your ending result, and you just use the normal distributive property that you learn in basic algebraic operations. You just give the number that is asked to be distributed to each of the participants of the matrix. In order to use this property, problems that ask you to solve the matrix equation, this past principle explained will be used in these problems. Solve the matrix equation. They will ask you to find the x and the y of certain problems that include matrices. For example, don't be scared by this one. At the end, it'll just ask you to find which are the x's and the y's. There you go, there is a complete solve the matrix equation. For right here, our first step would be parentheses, please excuse my dear Aunt Sally, which includes the distributive property shown before. Therefore, distribute the 3 to each and every one of the matrix participants that are included. Therefore, you end up with a 15x, negative 6, 18, negative 4 matrix. Since that was 3 times 5x, 3 times negative 2, 3 times 6, and 3 times negative equals this. Then you would have, it would still be positive, 3 times 3, 9, 3 times 7, 21, 3 times negative 5, negative 15, and 3 times negative y, negative 3y. And that would still be the same answer, since it does not ask you to distribute to the answer as well. In this case, they're only asking you to find the x and the y, which are here and here. If you remember your subtraction and addition properties, it is all about placement. Therefore, the 15x plus the 9 should give you negative 21, and the negative 3y should give you negative 24. We can set up two equations, which are taking the 15x plus 9 should equal negative 21. And that is just for the x. 15x minus 9 equal 15x equals negative 30 divided by 15. X equals negative 2. Therefore, for your y, you should have negative 4 plus 3y equals negative 24. Then you have plus 4 plus 4